Hello everyone, welcome to Kwiation Engineering YouTube channel. So today I'm going to teach you zone and pack controller interfaces under ATA chapter 21 air conditioning zone temperature control lesson number 8. So if you are still new to my YouTube channel, I am Keshara Vikramasinghe. Right, so now we will start the ATA chapter 21 air conditioning system zone control system lesson number 8. So today we are going to discuss about zone and pack controller interfaces. All right, so if you still not subscribe my channel, please subscribe my channel, and it will helpful for me to grow my YouTube channel, and it will helpful for you to gain more knowledge about aircraft systems. And if you have any questions or any comment, please comment below. All right, and also please share this video with your friends, relatives, any of the social media platform. All right, so let's go to the lesson. All right, so in this lesson you will gain the knowledge about zone and pack control interfaces in A319, A320 and A321 aircraft, right? So the zone controller crosstalk via internal buses and the pack controller crosstalk via external RS-232 connections, right? So today we are going to discuss SDAC, EIU, ADIRU, ECB, DMU, CFDIU, and the fans parameters, numeric parameters, anti-ice parameters, right? Okay, so LGCIU2, BSCU, right? And also in the end, we will discuss about two questions. All right. So number one is SDAC, System Data Acquisition Concentrator. So this is the SDAC 1 and SDAC 2, right? So system data information is transmitted to the System Data Acquisition Concentrator by airing buses for system monitoring. Right, so system data is transmitted to the SDAC by airing buses, right? System data transmitted to the SDAC by using airing buses. So you can see the yellow color are the airing buses for what? For system monitoring, right? So SDAC, the signals are system data informations, example temperature and sometimes the valve positions, and is used for warning and display, right? So you can see the actual view. So this is the rear avenue compartment in the aircraft, and this is the 85 VU rack. So system data acquisition concentrator number 1 here, right? So later lessons I will teach you in detail about these systems. All right, okay. So now next one, EIU engine interface unit. So this is the EIU number 1 and EIU number 2. So the zone controller provides data to both engine interface units, right? So both engine interface units, the data is coming from the zone controller, right? Secondary and primary. So each unit provides one discrete to the zone controller and one discrete to the corresponding pack controller. Each unit, it will send one discrete signal to the zone controller and also one discrete signal to the corresponding pack controller. It means EIU number 2 sent to the one discrete to the pack 2 controller, and EIU number 1 is sent to the pack 1 controller. All right. Okay, you can see this is the engine interface unit here. Number 1, rear avenue compartment, same 85 VU rack. So now EIU number 1 to pack controller. EIU number 1 to pack controller. The signals are this is not a single, it is signal takeoff thrust and used for the pack ram air inlet closure. And EIU number 1 to zone controller, they are signal, not the single, is signal are the HP fuel valve position and is used for bleed demand calculation. Now the zone controller to engine interface unit number 1 and 2. Zone controller to engine interface unit, it means EIU number 1 and 2. The signals they send increase engine power and used for bleed air flow increase. And another signal is bleed and anti-ice status used for thrust limit calculation. All right. Okay, now let's go to the ADIRU 1 air data initial reference unit. You can see ADIRU now number 1. So the air data initial reference unit 1, ADIRU number 1, send data to the zone controller for zone impact temperature control. This will send signals to the zone controller for zone impact temperature control. right? So now air data initial reference unit ADIRU number 1. The signals are aircraft altitude and used for zone temperature compensation and packed water extract outlet temperature limitations, right? So you can see here the ADIRUs. You can see 3 ADIRUs there, all right? And now next one is ECB, electronic control box. This is the ECB electronic control box, right? So yeah, you can see this is the electronic control box, and it is situated in the F cargo, right? F cargo. So the zone controller send data to the electronic control box. Zone controller send data to the ECB and receive an APU bleed valve open signal as a discrete signal. All right, you can see the zone controller send to the ECB. It means the zone controller will send signal to the ECB as a ring data and receive an APU bleed valve from the ECB. The zone controller receive APU bleed valve open signal as a discrete signal. All right, so now zone controller to ECB. Now this from zone controller to ECB, the signals are increased APU flow and is used for increased bleed air flow. And from ECB to zone controller is signals are APU bleed valve open and used for flow demand calculation. All right, just keep in mind. All right, so now let's go to the data management unit, DMU. This is the data management unit, right? So the zone and pack controller send system the zone and pack controller send system main status data to management unit, right? Data to the management unit for maintenance monitoring purposes. All right, so the zone controller to DMU, it means zone controller to the data management unit, they send PRV, it means pressure regulating valve positions. And pack controller to DMU, pack controller to the DMU, you can see is going to here, pack controller DMU, pack flow, water extract and pack compressor discharge and temperature, bypass valve and ram air inlet flap position. All right, okay, now let's go to the CFDIU, centralized fault display interface unit, right? You can see this is the actual view or live view, the CFDIU. Right, so the zone controller sends byte data to the centralized fault display interface unit for system monitoring, right? So this is the zone controller. Zone controller will send byte data to CFDIU for what? For system monitoring, right? So the CFDIU signals are byte data and used for temperature control system monitoring. All right, okay, now let's go to the fan parameters, right? Fan parameters here, right? So you can see the recirculation fan forward cargo compartment, right? Recirculation fan, this is the recirculation fan. There are 2 recirculation fan forward cargo compartment, right? So the zone controller receive discrete signals, right? The zone controller will receive discrete signals, right? From recirculation and toilet fans for monitoring. All right, so the fans, the signals are recirculation, toilet and galley and aft cargo ventilation fan operation and used for monitoring for transmissions to SDAC and CFDIU. All right, okay, now let's go to the pneumatic and anti-ice parameters. Pneumatic and anti-ice parameters, you can see pneumatic parameters and anti-ice parameters. All right, so anti-ice and pneumatic parameters are used to detect fault and the status of the bleed air system for transmission to CFDIU and EIUs, right? So anti-ice and pneumatic parameters, signals are valve position, low and high pressure, etc., right? So used for anti-ice system fault detections for the CFDIU and thrust limit calculations for EIU, right? Just keep in remember. All right, so now next one is landing gear control interface unit number 2. So here is the landing gear control interface unit number 2. Landing gear control interface unit number 2 send the ground flight signal to both pack controllers for pack ram air inlet flap operation. All right. So the landing gear control interface unit number 2, the signals are ground and flight signals coming and used for pack ram air inlet flap closer during takeoff and landing phases, right? You can see this is 94 VU rack and this is the landing gear control interface unit, right? So this is forward avionic compartment, situated in the forward avionic compartment. All right, so now next one is the braking and steering control unit. Braking and steering control unit, BSCU. Right, so here BSCU, BSCU send a wheel speed signals. Right, BSCU send a wheel speed. This diagram is wrong. Right, so right, BSCU send wheel speed signals to both pack controllers for pack ram air inlet flap operations. Right, so from BSCU you have to go the discrete signals. Right, so the BSCU signals are wheel speed and used for pack ram air inlet flap closure during takeoff and landing phases. All right, okay, so you can see this is the BSCU. Right, that is the end of the lessons, and now let's go to the question and answers. The first question I will ask: the pack controllers sent to the zone controllers. The pack controllers sent to the zone controllers. Answer A, the flow demand signal, and answer B, byte informations and pack status signal, and answer C, the byte demand signal. So what should be the answer? I will give you a few seconds, just think. Okay, the answer should be, answer is B, byte information and pack status signal. All right, okay, now the question number 2. To close the pack ram air inlet flap, the pack controller needs informations from. To close the pack ram air inlet flap, the pack controller needs informations from. Answer A, the ECB. Answer B, the anti-ice system. And answer C, LGCIU2, BSCU and EIUs. So what should be the answer? I will give few seconds for you. Okay, the answer is answer C, LGCIU, BSCU and EIUs. All right, okay, yeah, that is the end of this lesson. So thank you for participating in this lesson. So I think now you almost with me for almost 8 lessons with the zone temperature control under 8821 air conditioning system. So we have so many lessons, like, you know, this is for zone temperature control system, and next I will be going to teach like the ventilation system and the cargo ventilation, and cargo ventilation, cabin ventilation. So many lessons I have to discuss under 88 chapter 21 air conditioning. So stick with my channel, and don't forget to subscribe my channel. Don't forget to like, comment, and don't forget to share this channel especially. And then if anyone interested about aircraft maintenance, especially for Airbus, they can learn something from my channel, because I'm teaching for you the things what I learned. Okay, so in the next lesson you can learn about emergency ram air inlet operation. So I'm going to teach you as a next lesson, so you can stick with me. And again, thank you for participating in this lesson, and see you on next lesson. Have a good day for all of you.